Hi guys, I'm Shtuky. Today I will teach you how to make computer games from scratch, and we will train on the Roguelike game.
The game code consists of several parts. First of all, the libraries are included at the top to help to make games. Then the global variables are set, and then comes the main loop, which is the so-called main game loop. And then goes the functions that are included in the main function. These functions can show individual elements of the game. They are included in the main loop. The main loop goes around in circles as long as the game is running. Global variables are visible in any part of our program. Those variables that are set within a function are only visible within that function. We try to keep function main more minimalistic and clear. It will contain the main game loop. The details of this loop are placed in a separate function. Now let's see how the game program looks like in reality. And all of our blocks will be seen in examples. If we run the game, we see the rooms, corridors, and the player who can kill goblins. The game code starts with the inclusion of libraries, and both the standard libraries, in this case for the C language, and the specialized libraries for making games are included. Here, for example, I use courses. This library helps you make roguelike games. Next, we initialize the global variables. These variables can be seen anywhere in our code. Remember, we were talking about the main function. This is what it looks like, and this is where the main game loop is located. Inside main, there are its own variables, but they are local for this function. This is what the main game loop looks like. In this case, it's implemented via do-while circle. Inside do, there is a dungeon function. It's implemented separately. It already shows in detail how the game runs. And in main, there is just a short line that's called the game loop. Now, let's look at the function that describes the entire gameplay. This function is dungeon. It will describe all the main steps of the game. Now, I will briefly tell you how the code of this program is organized. To start with, we include libraries, mostly all standard ones, except for this one here. I use courses.h, which helps make roguelike games. We first initialize the global variables. Player coordinates, enemy coordinates, a number of scores the player earns while playing. These counters show whether the player is already placed, whether the enemy is already placed on the field, and whether we already have rooms, because we're going to create rooms or so-called dungeons, where the gameplay will take place. Next, we start the actual main loop of the int main function. We start by making local variables that we will need. Map coordinates that show the size of our field. We do not know it yet. We find the size of the field with this function that allows us to get the size of the screen of the terminal where the player will play, because everyone has a different terminal size. Here, we use some specific functions for the courses library. For example, we first initialize the screen, then we make the keypad work. After we have used these library-specific functions, we do the rest as usual. The normal programming begins. We make an array where we put the symbols. Either they will be the walls or they will be the rooms. We have an x-axis and y-axis, which is our game screen. And it has coordinates on the x, 0, 1, 2, 3, and so on through the game. They increase on the x to the right and they increase on the y to the bottom. As a result, each point on the screen has a coordinate that is described by some specific x and y. And it is these values that we will enter in our array. While it's empty, we just say that it will be of size y max, x max, which is this size that we got here using the getScreenSize function. Next, we run the main loop of the game, the so-called game loop. We do it with do-while loop, which means do something until something happens. And I have an escape button to exit the game, which is 27. So, until the player presses escape, which is 27 in ASCII, we're going to repeat this. What exactly are we going to repeat? We will repeat some function which will be written next. So, if the player pressed escape, then close the screen and get out. Here is our dungeon game function. We pass an array here, we pass in all these parameters. Since this game is largely based on randomness, like many other games, we need to set the parameter so that our randomness is more random. That is, we can basically just use rand, but it's a little bit predictable. And in order for the random numbers to be different, we use this thing with time. Time is used from our computer. It's different all the time due to the different number of seconds, and we end up having random different numbers all the time. So far, we have nothing at all. We need to build some rooms. Now we need to figure out what the coordinates of that room will be. So we ask, do we have a room yet? If the game has just started and we don't have a room yet, then the first part of the code works. If we already have a room, we jump like this. But as long as we do not have any rooms, we start here. So, we're going to need coordinates. What kind of coordinates we will need? It's room coordinates. X minimum and maximum and Y minimum and maximum to figure out where the room begins by X in the game and where it ends by X. We also need the coordinates of the center of rooms in order to draw the corridors between the rooms. As we need to write down data for the center of two neighboring rooms, so we need two additional variables. The two centers of the first room at X and Y and the two centers of the second room to draw a corridor between their centers in the future. And we'll also need another Boolean variable that can take a value either true or false. We'll call it collision. That is, we'll check if the room is already drawn or not, so that we don't have to draw a room several times in the same place. Now we need to fill our database of the playing field. Remember, we did map y x. First, let's fill this entire array with grid icons, that is, walls. We do this to make sure that there is no garbage in the array. So, at the very beginning of the game, if we don't have any rooms yet, let's first fill the whole game field with walls. And then already from these walls, we will remove these icons, replace them with space, and an empty space is formed, which looks like rooms. Let's use the database scheme as an example to show how the rooms might look. Here's our database. It has conditional cells with X and Y coordinates. And we put grids everywhere first. This will be the walls. It turns out that first we will have the whole database filled with grids. Then we will gradually assign some cells to empty values, space icon. And these empty values will form the rooms in our game. To do this, I make a while loop that starts here and ends here. It's such a big loop. In it, we will now assign coordinates to our rooms and we will do checks. As long as we have less than 11 rooms, generate random coordinates for the beginning of the room and the end of the room. How do we get these coordinates? I want the rooms to be random, so I use the rand function. To make sure this rand is not just random and that it fits the size of our screen, we use a calculation model from the maximum value of x or y max. These x max and y max values we already got here above. That is, we already have this data. It is passed into the function. Consequently, if we run model from this maximal x, we will never get more than x max value. We'll get a value from 0 to x max. And now I just do rand and say, make some random x. But I also need the room to be not too small and not stacked at the beginning or at the end of the screen. So I add some constraints. First, the resulting coordinate must not be 0, so that room doesn't end up close to the edge of the screen. But I also don't want the room to be too small, so let the coordinate be greater than the maximum coordinate minus some value. This generates all 4 coordinates for the room. Now we need to check if there are any collisions. That is, if there is already a room in some place, the second room must not overlap with it. We list all collision conditions. If a cell is already empty by x or y, and in order for the rooms not to be built quite close to each other, we add another 2 number. So there will be at least 2 cell walls between the rooms. If a collision occurs, we reset this loop. You see, we have a while collision condition, which means that we will keep generating new coordinates until we have nowhere to intersect. So, we will generate the coordinates of 11 rooms that don't intersect each other. Now we use the for loop to put all of our 11 rooms into the map YX database, increasing the number of rooms by 1 here if we have entered it into the database. Next, we start drawing corridors. Let me show you again what the game looks like. There is a gaming field on which there are walls and rooms. Between the rooms, there are lines. These are corridors. The point is that the player can move from one room to another so that all the rooms are connected to each other. Corridors can be drawn in different ways. There is a very convenient way if you just take the center of a room and the center of the next room and draw a line between those centers. And how do you find the center of a room? We have to take the length of one side, for example by x. We know this point, x minimum of the room. We know this point, x maximum of the room. We take this whole line and divide it in half. To find the absolute value of the coordinate, we add x minimum to the obtained value. So, we find the x coordinate of the center of the room. Similarly, on the y-axis, we know the top point, y minimum of the room, and we know the bottom point, y maximum of the room. Let's take this whole line and divide it in half. Now we know the center of the first room, and by the same principle we will find the center of the second room. And knowing these two centers, we can compare them to each other, which one is higher, which one is lower, to connect these centers with a corridor. We can only start making corridors when we already have more than 2 rooms, because we need to draw a corridor from one room to another. I save the values for the center of the first room in x and y, but I also need to save the values for the center of the second room. To do this, I use additional variables. We will first find the first center, and it is generated, as I said, by subtracting the maximum from the minimum coordinate divided in half plus the minimum room coordinate. This is where we'll get the center of the first room by x and y. As soon as the second room is generated, we just assign this value to a new variable and recalculate this one for the next room. In the end, we'll always have the center of the previous room and the center of the new room at the same time. Next, we will start to use them to build the corridor. We now have 2 central points. We introduce the variable yPath, which will draw the corridor. Let it be equal to the center of the old room. As long as it is not equal to the center of the second room, fill the array with spaces until the 2 centers are equal to each other. If the first center is smaller, we start to increasing the coordinates. But if the opposite is true, we will decrease the coordinates. What does this look like on the game screen? Let's say you have the first room higher than the second room. Accordingly, you will need to go down, that is, build a line from more to less. If it were the other way around, you would first generate, say, this lower room, and then you would have this room. Respectively, its center is higher than the center of this room, so you have to generate a strip upwards. You compare what's bigger and what's smaller, and you draw either up or down. In code, this will either be plus plus or minus minus. We do the same thing to the x. So we add the coordinates of the rooms and the corridors between them to the array using this algorithm. And then we have the actual drawing, which means that we basically just filled in the database with values where we have what, and now we need to draw what's written in this database. How do we draw it? In C language, we have the printf function, but if we use the courses library, printf becomes printw, which is the same thing. So we want to print on the screen what we already have in the database. In the array, we have grid and space icons. Spaces create empty places. We call it rooms and corridors. Next, we need to understand what will happen if the player walks on the field. We have this option. In the courses library, we can use action for keypad input, which would be, for example, up arrow, down arrow, left or right arrow. If the player presses an arrow like this, let the player icon move around the field, but let it only do so as long as there are no walls. Let's make it so that the player can walk around the room and corridor, but can't go through walls. It looks like this. Look, here's our game. Here's our player. Player is this kind of @ icon. Accordingly, I press the arrows on my keyboard and I can walk, but I can't go through the wall. How do we put this player on the field? We do this also by using the flag, which checks whether the player is placed on the field or not. If the player isn't placed yet, then place him at some random spot. We generate a random x and y and do it as usual with rand model xmax or ymax. That is, its coordinates can be a random number from 0 to the maximum value. Then place the player there and change the flag. The player is already on the map. Now, if we already have a player placed on the playing field, then we need to put the enemy here as well. After all, the essence of the game is that the player walks around the rooms and fights the enemies. We also have a flag that checks for an enemy on the field. If no enemy has been placed yet, just as well generate some random coordinates where we will place this enemy and write these coordinates into our database, which we have in common for all. But of course, we want the enemy not to fit where there are already walls. We want him to fit where there is empty space. The enemy is the letter T. They are placed somewhere in random places. Now we need to make it so that the player and enemy can fight. Let's write down the battle conditions. The battle system can be made different. You can make up as you like. But in fact, the player and the enemy must somehow meet on the field, and if our player attacks the enemy must do something, maybe move somewhere or disappear. And if the player defeats the enemy, the player should get points or some kind of money for it. To do this, we write what happens if our player meets the enemy. If their coordinates intersect, that is, they are equal to each other, then what to do? In my case, I just move the enemy to a new random location and give a player a random number of points from 0 to 15. That way you can give players bonuses. He defeated the goblin and got some money. That's basically the end of the game code. All we have to do is to display what's going on in this game. Let's print the player, let's print the opponent, and print the number of points the player got. Let's check how the game works. Now I catch the goblin. So far I have 0 points. I defeated one goblin and look, got 5 points. Now let's see how many points I have if I catch another goblin. That makes 8. A random number from 0 to 15 is added each time. So, the basic game is ready. You can customize it and make a real roguelike using this code. Thank you for watching. Do not forget to subscribe to my channel. And if you have any questions, leave me comments. See you in my next video. Bye!